Dear students, welcome to the course of Design of Power Electronic Converter. As you are in your internship, we are giving this course in the online mode. Uh, Throughout your engineering program, you have studied various subject electrical machines, power electronics, control system, and electric drives. So in this, we are going to take a next step. That is, we have mostly analyzed the converter circuits. We have solved some numerical problems based on the circuits what we have learned. So in this course, we will learn how engineers actually design converter that is used in applications like electric vehicle, renewable energy systems, industrial drivers, then some modern electronic equipments. Okay, the objective of this course is not merely to understand the converter circuit, but to develop the ability to transform a circuit into a practical and reliable and a hardware ready design. So this is the basic objective of this course, Design of Power Electronic Converters. So now let's understand why this subject is important. Uh, Power electronics converters are energy control units that we are already knowing. This is used behind almost every modern electrical systems. Whenever electrical energy has to be converted from one form to another, a power electronic converter is involved. So this we have already learned in the power electronics and other subjects. So there are some applications in which these converters are used. One is electric vehicles. Converters are used in chargers and the traction drives. Then converters are used in solar energy systems. It is having inverters used in it. Then it is used in the battery storage system of this renewable energy system to convert the energy and uh, store the energy. In industries, converters are used in SMPS, UPS, etc. Even in aerospace systems, railway applications, data center, power electronics plays a crucial role. So you can see the block diagram. So when you observe this block diagram, um, it shows the converter, power converter. This power converter controls the load. So the understanding of power converter is very important. Okay, we need to design the power converter, which is very much relevant for modern electrical engineers. So you have chosen this subject as an elective, but many students are ask a very important question like, where is the subject useful in my career? Okay, so these are few areas in which this subject will be relevant. Okay, uh, it is used in EV powertrain. It is used for EV powertrain engineers. Another area is the solar inverter design engineer. Many companies are recruiting R&D engineers and hardware engineers. Then some are in testing, validation, and checking the reliability. So you can work as a power supply engineer also. The skills, so when you complete this course, you will develop the understanding of power converter, interpreting the data sheet, then how to do the thermal management system of converter, then uh, how to design the driver circuit, gate driver circuit of the converter, then EMI control and hardware implementation. Okay, so this is an industry oriented skill development course, and it is highly valued by the companies working in all these areas. So now let's see our learning journey. So we have this subject divided into 5 units. First unit is converter analysis. Second unit is your device selection. Third unit is about the gate driver circuit and the protection circuit. Fourth unit is about the thermal and magnetic design, and the last unit is electromagnetic interference, and finally the hardware design. So this design of power electronic converter journey is divided into three parts. At the start, it is the analysis. We discover the various converter principles. So here especially we are going to study DC to DC converter. In that we focus on buck converter. So if you learn buck converter, you can automatically design a boost and buck boost converter. Then along with that we will study about H-bridge inverter. Okay, then we will build based on the selection of the components and the protection circuit. We build the circuit, and finally we convert that model into a hardware and learn how to practically implement the converter for any of the applications. So we need few prerequisites. So I am assuming that you have already learned on your, you are remembering all these things what you have already learned in your previous classes. You have to be aware about these subjects like power electronics, semiconductor. What is a semiconductor device? Which are the very basic converter circuits like AC to DC converter, DC to AC converter, AC to AC, DC to DC converter. What is the PWM concepts, pulse width modulation? Then you have to understand how the circuit analysis and measurement is done. You have to understand some basics about the magnetic components. Okay, so when you are going through, when you are completing this, you will learn how to analyze a practical converter, how to select a device from the data sheet, then how to design the protection circuit, thermal analysis, thermal circuit, and your electromagnetic issues. Okay, so the ultimate goal of this subject is to bridge the gap between the studying a converter and designing a practical converter system. So let me quickly test your understanding. So this is not having any marks. So you have to just think about the answers of this question. So I have given few questions here. Why a buck converter is always having an inductor at the load side? Whenever you have a buck converter in any of your circuits, you can see that there is an inductor connected at the load side. Okay, what is the need of that inductor? Now second question is, what happens if MOSFET switching loss is ignored when you design a circuit, when you practically design a circuit, if you ignore the switching loss? Third question is, why does a gate driver circuit need isolation? Okay, we know the converter circuit, we know the driver circuit, but we need to isolate this control circuit and the power circuit. So what is the need of this isolation? Now fourth question is, how EMI is created in a converter circuit? Okay, so no need to worry about the correct answer of all these questions. So this is not a test. It is just some questions simply indicate where we are starting. Okay, where we eventually reach by the end of this course. So we will get the answer to all these questions towards the end of this course. So many engineers think that circuit diagram is correct. If your circuit diagram is correct, then your design must be working. But unfortunately, in practical engineering, it is not simple. Like even though your circuit diagram, your schematic diagram is correct, your converter may fail to work. Okay, there are various causes behind it. It may be a wrong selection of MOSFET. You are selecting a MOSFET which is of wrong rating. Then there may be a poor gate resistance selection. Okay, there may be inadequate heat sink. There may be high layout inductance, or maybe missing of the EMI filters. Okay, so for a power electronic converter, even though we are having a good schematic diagram, maybe because of the issue in layout, maybe because of the issue in your thermal system, maybe because of the rating of your devices, there may be chances of getting the failure of devices. So we will learn how to move from a theoretical design to a reliable hardware implementation. Let me ask you an interesting question. Uh, can a converter be designed with 100% efficiency, uh, minimum cost, zero cost indicates minimum cost, zero electromagnetic interference, very small and compact in size, and highly reliable? I'll repeat my question. Can you design a converter which is having all these properties like 100% efficiency, minimum cost, minimum electromagnetic interference, simple design, and which is highly reliable? The answer is no. Engineering is always about compromise. We need to compromise one thing or other when you design a system. For example, when you increase the switching frequency, uh, increasing the switching frequency, your component size will decrease, but switching losses will increase and electromagnetic interference will increase. If you improve the thermal management system, uh, it increases the reliability, but again cost and size will get increased. So every unit of this course is an attempt to answer one question: how we can design the best possible converter while balancing multiple conflicting requirement. Okay, so we are going to design a converter which is best possible, optimizing all these characteristics. So this is why converter design is an optimization problem. So, power converter topology evolved significantly. Okay, initially we were using power diodes. Okay, uh, then thyristors were introduced. This enabled controlled power conversion because power diodes are an uncontrolled device, but thyristors are a controlled device. So it started with the controlled power conversion. Then MOSFETs and IGBTs were implemented, where MOSFETs made for high frequency conversion system, and IGBTs enable medium and high power conversion system. Okay, and today in latest innovation, wide bandgap devices like silicon carbide, gallium nitride are revolutionizing the power electronic field. Okay, as device technology evolves, uh, converter design, thermal management system, all these associated things are more evolved. So we have to uh, do proper design of all these parameters when you are designing a power electronic converter system. Okay, so we are having this 5 units. So in first unit we will study about the buck converter design, how to select the inductor and capacitor for buck converter, H bridge inverter, uh, then bipolar and unipolar PWM systems. So this is your first unit, and in second unit we will study about the devices, MOSFETs, IGBTs, thyristors, all these devices which is used for the design of the converter. So we will analyze the data sheet, and by analyzing the data sheet, how we are able to understand which device is to be appropriately used for the converter. Okay, now unit 3 is about the gate driver circuit and snubber circuit. Okay, a semiconductor switch needs PWM signals for switching. So we need to study how to generate this proper gate or at proper value of gate voltage and current, how to design the isolation system, how to design the protection system. So we will learn about the snubber circuits, then all practical gate driver circuit in the third unit. Fourth unit focuses on thermal and magnetic design, because the converter may be electrically correct, but still it failed to work because of excessive temperature, increase in temperature. Okay, so we need to understand what is the junction temperature, how heat single is selected, what is the magnetic core loss and copper loss. Then thermal design is very much important because reliability and lifetime of the converter mainly depend on the temperature. And in last unit, electromagnetic interference and hardware design, we will study how to design a hardware, how to design the PCB. So we will study the electromagnetic interference generation measurement technique and how to mitigate the electromagnetic interference. So this is throughout from syllabus 1 to 5. Okay, so by the end of this course, you will learn all these things like how to analyze practical converter, how to select the device. So this will lead to make you efficient for this type of job opportunities. Along with that, we are integrating AI into this subject. So, for interpreting data sheet, for converter design verification, for some case studies, for doing some MATLAB simulating and preparation for some questions, interview questions, we will use the AI tools. Okay, so this is one simple example AI prompt I have given. You can try this and try to get the answer for this. Okay, but when you are using this AI result, always verify that the output is verified by using some equations and the data sheets and standard references like IEEE references. Always verify this whether the answer given by the AI is right or wrong. Okay, these are the learning resources like already in the syllabus. Textbooks are mentioned. We are following the textbooks of Net Mohan, Rashid, and Bimbra. Along with we have some advanced textbook also, and there is one online NPTEL course, Design of Power Electronic Converter. This is an archived course, so you can listen to the videos of this course for your reference. Okay. So these references will improve your practical understanding. Okay. Then along with that, I will share you some data sheets and some simulation examples with you. The assessment for this subject is carried through these four parameters. You will be having assignment 1, assignment 2, your LMS test and LMS test, out of which best 5 will be selected. And there is one case study. Okay, I will guide you how to do the case study and you have to submit that case study. Okay, so this is the assessment techniques and you will be having 40 marks for your CC and um, remaining marks will be remaining 60 marks will be given for your NSEM exam. There is no NSEM exam for this subject. Now I would like to conclude with one important idea. The converter is not just a circuit, it is a design system. Okay. So throughout this course, we will analyze the circuit, we will do the thermal design, we will select the device, then we will do how to control the EMI, we will design the protection system, and finally we will design the hardware of the system. Okay, so by the end of this semester, I hope each one of you start thinking not like a student but like a future power converter design engineer. So thank you for selecting this elective for this semester and looking forward for a new journey with the first topic in the next lecture. So this is the introduction of this course. Thank you so much. We will see in the next course.